So we continue with what we done last time. So last time the discussion was Gaussian distribution, and we talked about the binomial distribution. Basically, we said that the Gaussian very well known, very popular in many applications. We gave different examples and how to calculate it, and we presented the table of the Gaussian CDFs. We normalized the Gaussian CDF and how to use it to plug in with specific Gaussian distribution, specific mean and specific range. And then we talk about the binomial, and we say that the binomial distribution is a distribution where we ask a question about repeating and experiment, where the experiment has two outcomes, hidden pass and fail, hidden fail, and so on. Basically, one has a probability of 2, has a probability of interesting, has a probability of 1 minus 2. And in this case, we ask the question of what is the K out of N successes, for example. And we said that, okay, K out of N is N to scale, and then P to the power K, 1 minus N to the power 1 minus N minus. And we gave also examples about this. Today, we're just to discuss more discrete values, and we'll talk about some continuous solutions, uniform explanation. And we'll give some examples about it. You know how when to use them as okay, so that is considerable here almost. So the point, so basically we are done with the binomial. Limit limit binomial can about how many successes out of N, and what is the amount of K successes. Now if we allow N to be very, very large and P to be very, very small, so as N increases, it becomes extremely large. The number of repetitions is very, very large. And P, which is the probability of success, is very, very small. In this case, we approach what we, why N multiplied by P is a constant. So it's a number that is real. So it's not something small. Then the binomial distribution converts into approaches, what we call the Poisson. Poisson distribution has a probability or a PDF that looks like this. Again, it's a discrete, it's a basically discrete random variable. So basically, it has the PDF looks like series of deltas shifted at k. So if x of x is a series of deltas shifted at k, k equals 0, k equals 1, k equals 2, and so on. Where the probability of the PDF, or the probability of the random variable equal k, equals e to the power k divided by k factorial multiplied by e to minus. So the probability that x equals k equals whatever beside the delta. Okay, it's e minus b, b to k divided by k. Okay. Now, first of all, we would like to understand how does it look like, the different parameters of it, and then how to use it. Okay. So this is a PDF. This is the CDF. Again, the CDF is a series of step functions. Everyone at k with the amplitude of the step function, again equals to the probability that x equals. So it looks like step function. So here we're presenting 3 different distributions, one with b equal 1. Later, we will talk about in chapter 3 the average. Then basically we'll talk about that b is the average. Until now, we did not talk about moments and averages. However, b will represent the average. So you can see that if the average, if the b is small, then you can see that most of the probability is focused upon small values around 1, 0, 1, and 2, and then it decays very quickly. It becomes almost 0 after 4. Rather, minimum b equal 4, you can see that it's focused around 4. And the maximum happens to be around 4, and it's smaller before, it's smaller after, and it decays after like 10 years. If B is larger and larger, it becomes more shifted to the right and more spread. So as you can see, as B increases, it becomes more wider distribution and shifted to the right. This is, as we mentioned, B is the average value of the distribution. Okay. Now, if you look at it in the CDF point of view, you can see that in the yellow one with the B small, you can see that it saturates to 1 very quickly. So the probability that X is less than probably 2 is almost 1. Most of the distribution, most of the probability, total probability of 1 is focused around in this small area. 0, 1, and 4. Whenever B equal 4, it's a little bit more distributed. B equal 10, it's more distributed. So the average, so it's unlike the Gaussian, changing the average, the center of the graph changes, the location of the graph changes, as well as the variance is how spread it is. In the Gaussian, the mean changes only the location. The variance is clear? Now, where do we see this Poisson? Poisson is usually applied in problems that look like this. If I have a production line and I'm counting the number of defective units, for example, basically it's used in what we call counting type applications. So you have a production line and you have defective types that arrive randomly. Defective types, parts, e.g. in a random way. And how does it arrive in a random way? It arrives according to what we call the Poisson distribution. For example, if you are looking at number of telephone calls arriving to a certain station, the number of electrons emitted from a small section of a cathode. So think of that way. If you go into a gas station and you look at number of people, number of cars arriving at the gas station. So usually it's related to waiting time, waiting in queues, and counting application. For this example. أي سؤال يا شباب؟ طيب, the way we look at it is, as I mentioned, counting type applications. So we look at time interval of t, specific time interval, and we say that, okay, the average arrival rate is lambda. So within 30 seconds, the average arrival rate is lambda. In this case, how many arrivals arrive is basically B, which is number of arrivals per second, arrivals rate per second, and T is duration. Okay, in seconds. So if we have arrival rate in per second and duration per second, then what is this unit here? Is it rate or the number of arrivals? In T seconds, right? So this is number arrivals in T seconds. So if I start with certain time observation, I ask you, if you are at that gas station, in 1 hour, how many cars arrive at that gas station? In this case, you need to watch it for a long time and see, okay, I have seen that in per hour, roughly speaking, we arrive, there are, for example, 10 cars arrive. In this case, lambda will be 10, and T will be the 1 hour that I asked you to observe. After that, I ask you, what is the question? For example, if I watch for 5 minutes, what would be the probability that I have 2 hours? Then we apply the Poisson distribution. It would be probability of X equal 2, and then we apply this. We'll give an example. Let's have an example. It will be more clear. So the example says the following. We have a gasoline station. Cars arrive according to Poisson distribution. So, and why is it Poisson? Because it happens that most of the counting problems like this, where there's a waiting time and cars arrive in a random way, in general, cars will actually hang. Usually, people, when they modeled it, they found that they phase before small. So it's like regression. It happened in the nature that many applications are modeled by regression. Similarly, it happened in the nature that a lot of accounting applications and waiting applications, waiting line applications are following the portions. Okay, because of that, it's a very important decision because it solves many problems. So cars arrive at a gas station according to Poisson distribution with rate of 50 per hour. So this is what? What do we call this 50? Lambda. So it's 50 per hour. It's the number of arrivals per hour. So lambda here is 50 per hour, cars per hour, or 50 cars per minute. You want to solve it in hours, in minutes, doesn't matter. Like whatever unit you use here, use it for the rest. Now there is one gasoline pump that takes 1 minute to obtain fuel. So the service time is 1 minute. Okay. So basically, T that takes serve one customer is 1 minute. Then in this case, if I want now to see, if I look at certain period of time, then what is B? B will be the number of arrivals per minute multiplied by how much time I need to serve the customer, which is lambda T, which is 5/6. Now this is the problem setting. Now I can ask you any question. I can ask you, for example, what is the probability that a waiting time will occur? When does a waiting time? When does a waiting line? When does a waiting line happen? When there is more than one arrival at the same time, because we have one gas station. So basically, more than one arrival means waiting time. So the probability of waiting time here now you need to translate from the word to what it means mathematically. It's 1 minus probability that x equals. It's probability equals to probability x larger than 1, right? Which is equal to 1 minus probability x less than or equal 1. That of a discrete equal is very important. Well to put it. So 1 minus x less than or equal 1 by definition is if x 1, right? Now, what is this? This is equal to, what is this equal to? It's equal to what? When does x less than or equal to 1? I will say when does it less than or equal to 1? When it is equal to 1 or 0. You should exclude it. It cannot be 1 and 0. So it's probability x equals to 0 minus probability x equals 1. Right? What about what is it equal? What is probability x equals 0? Look at it here. X probability is then whatever next to the u or the delta. U in fx, and the cf, the delta in pdf. So what is the probability that x equals 0? A minus 5/6, right? Multiplied by current. 0 to A to 0 to 0, sorry, B to 0. What is B to 0? 1. Divided by 0 factorial, which is by definition 1. So it's B to 0 divided by 0 factorial, which is by definition. Minus, what is the probability of x equals 0? X equal 1. A2 minus B, which is 5/6, multiplied by 1, sorry, B, which is 5/6, to the power 1, divided by 1 factorial. Now solving this will give you this, which will give you 0.2. So basically 20% of the time you will have line waiting. ولو تيجي كده اللي نحطها هذه الحاجه اللي بيدورها مره في اليوم هتلاقي انه ما تصير 5 مرات اللي بيدورها they will be waiting time. Somebody will do it. How do we do it? How to translate from the words to the parameters? setting of the problem, and then how to use the PDF to find the probabilities. I can ask you another question. What is the probability that nobody is in the gas station, in the station? No car. No car is in the station. ايش رايكم؟ أول شيء دائما حول الكلام إلى إيش؟ إلى probabilities. اوكي دائما يعني probability of whatever الكلام حول probability هذه إلى x equal ولا larger ولا less than event on x. What is this? Yeah. And now after I find translation of whatever in the words into x equal كذا ولا larger, then I go to the PDF. What is the probability of x equals 0? I already found it before. It's e to minus 5/6. Right? Whenever you say you find an event that is asked to do, just translate أول شيء إلى math. That is don't skip steps. لأن steps هذه مهمة عشان ما تلخبط. This one? Yeah. الآن نحن قلنا probability of waiting in a line يعني تروح تلاقي أحد assistant. إيش معناها؟ You have one gasoline station, one pump. معناها إذا في أحد جالس يعبي أي واحد ثاني يجي means that the probability to have a waiting line that I have one larger than one. If I have one, he's self. No, it's not waiting. If I have more than one, strictly more than one, whatever will be there, he has to wait. عشان كده it's strictly larger than. أو ممكن تقول two larger. هذه نفسها عبارة عن probability of x larger than or equal to. نفس الشيء. Okay, تفضل.
I want to know the probability of waiting time will be more than 5 minutes.
Probability of what?
The waiting time will be more than 5 minutes.
Waiting time, we did not talk about it. But we'll discuss it later after I learn the questions. But here we're just talking about the arrivals and the observation. There's a when you come to random process, there's a Gaussian random process, Gaussian random process. That time you can talk about. The function? لا هي this is the function, this is the CDF that explains how is probability accumulates with increasing الفانكشن اللي اتكلمنا عنه زمان. فعادة في الديسكريت it's series of step functions شكلها كده. Step function, step function, step function. The length of the step function, the amplitude is equal to probability of x equals k, whatever k. Okay? So U في ال CDF with delta في ال PDF to describe the function. لكن the probability that x equal k is whatever next to the difference. هي the step function. This is to enable you to plot the function. أي سؤال ثاني شباب؟ Another question. Now, packets arrive at the internet router at a rate of 20 packets per minute. So what is this? Lemon. So lemon. And the router needs 3 seconds to serve the packet. What is this? If the router can serve 4 packets at a time, this gives you the capacity. The filling station can serve 1 at a time. This is 4 at a time. Find the probability that a new coming code or block packet will not be served. ايش يعني؟ Find the probability that ترجم هذا will not be served إلى event. Probability that larger than, strictly larger than, كم؟ or larger than or equal to. So this is basically what we are looking for. In order to find this, we need to find, first of all, the setup of the problem. So delta equals 20 packets per minute and time is 3 seconds. So you need to change either second or minute. Doesn't matter. Change one of them and compare the rest. So B, which is the average of the average arrivals, will be lambda T, which is 20 per minute multiplied by minute per second. So uniform distribution. These unified units, and then multiplied by 3 seconds gives you 1. Now, from here, probability that x equal k in general will be e to minus b to k divided by k factorial. Putting k here, replacing k and k will give you e to minus 1 divided by k factorial. So this is k, not 1. Replacing b, I'm sorry. b1 and b1 will be e to minus 1 divided by k. Now, finding the probability of blocked service is probability that x larger, strictly larger than 4, or 1 minus probability that x is less than or equal to 4. Now, simply you need to find probability that x is less than or equal to 4 is the summation from 0 to 4 of probability x equal 0, 1, 2, 3, and 4. So simply you need to find this. Probability of x equal 1 is just plugged in here. E to minus 1 divided by 1 factorial, e to minus 1. Probability x equal 2, e to minus 1 divided by 2. X equal 3, x equal 4, and so on. Probability of x equals 0 is e to minus 1 divided by 0 factorial. 0 factorial by default or by convention is equal to 1. So the probability of blocking a call or a packet will be equal to, in this case, 3.66 multiplied by you can ask different types of questions. Answer. Any question about the question? Which one? Where are you? The two? Yeah, انت عندك هنا اول واحده اعطتنا هذه، ثاني واحده اعطتنا e to minus 1 which is 1 multiplied by e to minus 1. الثاني اعطتنا half. الثالثه اعطتنا 1 over 6, 1 over 24. So it's 1 over 24, 1 over 6, 1 over 2, and here we have e to minus 1. So it should be 1, right? ليش؟ لأن عندي أخذت common factor e to minus 1. So this will be 1, right? هذه 1 صح؟ And half and 20. I think I'm mistaken. So anyway, this will be different. Thank you. Minus 1. We got the first and the second. With x equals to 1. Ah. X. No, so basically they are equal, and because of that they are summed. Yeah, thank you. So okay, thank you then. So basically this is e to minus 1, this is e to minus 1, and because of that we have 2. Because this is 1 minus the probability that x is less than or equal to 4. What is the probability x is less than or equal to 4? It's either the probability that x equals 0 or 1 or 2 or 3 or 4. They are mutually exclusive, so you add. You cannot have x equals 0 and 1 at the same time. Other questions, sir? Okay. So basically this is Poisson. It's very important to understand, do some practice about different applications, and you will see it's straightforward. Now we are done with the discrete distributions. Let's talk about a little bit on some continuous examples, continuous distributions. Remember when we talk about the phase of the signal arriving in a y distribution. Usually this phase has a distribution between minus pi, minus 2 pi, minus pi, sorry, 2 pi. So this is f theta of theta. So this is an wireless communication. So basically it's equally likely that the signal will have a phase between minus pi and pi, or between equally likely. There's no reason to believe it will be biased here or there. تذكروا الspinning of a wheel, okay, and you just have a counter that shows where you stop in a continuous fashion. Okay, so basically you have a counter here that stops at certain pointer that stop. Now, when you ask yourself, what is the probability that it stops between any 2 points? It's uniformly distributed to stop at any place, right? Because there's no reason to believe that it will stop here more frequently than here. It's a fair rule. هذه الابلكيشنز يعطينا one variable called the uniform variable or the uniform distribution. Why is it uniform? Because it's equally likely that it takes any value between the maximum and the minimum of its range. So in general, the PDF looks like this. It goes from A to B. So the minimum is A, the maximum is B, and because it's a total product of 1, right? So the area under the curve has to be 1. So the amplitude will be 1 over B minus B. So if you ask yourself now, what is the probability that X is between A and A plus 1? Then what is the probability here? X between A and A plus 1. ايش رايكم؟ شباب؟ ها؟ It's 1, it's A plus 1 minus A, right? Divided by B minus X, which is A cancels A and it will be B minus. هذا مثال. And you can ask anything like that. So basically the point is here, the probability that X lies within certain period is the width of the period divided by B minus. Okay, so in general, the probability that X is between A and C in a word, it will be probability that X between A and C. وهنا continuous ما تفرق وين equal. It will be equal to كم قلنا؟ C minus A divided by B minus A. Okay. Now, so basically the PDF looks like this. It's 1 over B minus A for X between A and B, and it's 0 otherwise. This is mathematically the way we write it. This is how we engineer pictorial. And if we integrate this to get the CDF, when integrating a constant, you give us what? Linear line, right? So here you can see that the CDF represents how probability accumulates over with increasing X. So you can see that as X increases from A to B, the probability accumulates linearly. Okay, so as for example here you ask, what is the probability that X is less than or equal this point? It will be the width of this point divided by the total width, right? So as the width increases, it increases linearly. مثل ما شايفين هنا. As the width increases, هذا هو الويدث. It increases linearly. Okay. Another application is those of you who have taken feasibility. feasibility يحيى كده. خلص في حاجة اسمها quantization. When you convert from analog to digital communication, you need to quantize, which is sample. When you sample, you basically take certain shots, time sample. After that, you need to convert into codes. So you need to quantize. ايش يعني quantize؟ قرب السامبل إلى أقرب للدقيق. لأن هذا التقريب gives you what we call, it's called quantization, and results in what we call quantization. Again, quantization error can be modeled using uniform distribution. So it has many applications in communication and other applications. Right. Okay. So we have an example here. So we can move to the next distribution. طيب, an exponential distribution. Exponential distribution is a distribution that, again, important because you can see it in different applications. For example, in wireless communication, the power received because of the reflections. الآن جواب finger divide يجيك السيجنال من البلاي ستيشن برج. البرج هذا قبل سيجنال بس تطلع من البرج كبر يعني صار تضرب في المباني في الجدران في السيارات فتجيك السيجنال ايش؟ summation of many different versions. Okay? الآن هذه many versions adds what we call مرات تجمع كبيرة تجمع فوق بعض انتين مرات تنسي بعض. اللي يحصل ان السيجنال تصير بعدين. The power of the received signal looks like an exponential distribution. So it starts from zero بالنسبة لل power of the received signal. So it looks like exponential distribution. What is an exponential distribution? طبعا نفس الشيء. This you can see it in the waiting time in a line. If you are in a line, تسأل نفسك أنا كم waiting time اللي ممكن أجيبه. Well, it's modeled according to exponential distribution. So it has these two main applications. الآن the PDF دائما نتكلم عن الشكل بعدين نتكلم عن equation. The PDF looks like this. Before zero, it's nothing. So the probability of total one will never happen before zero, before A. And after A, it peaks. It's the largest probability around A, بعد كده decays to zero after certain amount. Okay, so the largest portion of the probability equal 1, which is the total probability, is concentrated where each now? Around, basically next to A, just right after A. Not around A. Before A, it's zero, it cannot happen. Just next after A, most of the probability is focused, is concentrated. Okay, and because of that, we say that in wireless communication, the seed power, we call it fading. Why is the big problem? Because most of the time, the average ممكن يكون هنا, average of the power of the signal. Most of the time, the signal is below its average. هذا يخليك انك تشوف النويز يخرب السيجنال. So basically, it looks like this. PDF again. Before A, it's nothing. After A, right after A, it's most of the probability is focused, which is total one, and it decays as you go away from it. Now it decays faster as A should have. B increases or decreases? Decreases. As B decreases, this decays faster. As B increases, it decays slower. So خلينا نقول هذه for large A or large B, sorry. This is for large B. This would be for small b. This is for larger b. Larger. But we later on will say that it's the average of the signal, of the distribution. So if we understand what does it mean physically and what does it mean in terms of the way the total probability is distributed, then we can write it in terms of math. It's exponential shifted by A. So this A is the shift here. If A is 0, then basically it's only exponential. And B here represents, as you mentioned, the speed of the rate of decay, or how focused the distribution around, close to A. Is it focused or is it distributed? Now, تلاحظوا small a, small b means that this is large. This is small b because one over this is large. And larger b, this is small and wider. Again, the area under the curve is always equal to come. Yeah, طبعا. You can write it this way, or you can write it as 1 over b e to minus x minus a divided by b u of x minus a. Either this or this. هذا السمر. Now, if you want to find the CDF simply you need to integrate. integrate this will give you this function. So basically, again, the probability that x is less than a is always 0 because it cannot take times less than a, and it starts to increase exponentially. Sorry, not exponentially, logarithmically, I would say, as this 1 minus e to minus. Okay. Again, b is the average resolution. So you can see here as b increases, small b, you can see that the average is close to a. Small. Larger b will be a little bit shifted because the distribution is wider. أي سؤال يا شباب؟ تكلمنا الابلكيشن fluctuation of signals, wireless, radar. طب example. معلش اليوم في كذا distribution بس the way it goes. أولنا في الرياكشن، أولنا في البي بعد كده خلاص نمو. نفس الكونسبت. You need to understand ايش ال PDF. Now we understand what the PDF and CDF is. Then it's available to complete the chapter. PDF and CDF will be repeated 1,000 times in the rest of the course. And random variable and distribution and so on. So if you don't understand this very well, master them, you'll start to get confused as well as we move. طيب الآن an example. P is received by radar from an aircraft. Okay? P here is the power received. So basically, the PDF of P looks like this. It's basically centered around 0, or starts from 0. Okay, 1 minus 1 over P0. P. Okay, and it decays to 0 as well. P0 here is the average. Okay. P0 is the average amount of received power. Then, what is the probability that the received power is above its average? Remember, you know, because of this, you will see that P is here, P0, which is the average. You can see from the plot that most of the time, the signal is lower than the average. ليش؟ لأن معظم ال probability of 1, معظم ال area under the curve is focused lower than the average. Now we would like to find what is the probability that the received power is above the average, larger than the average. It's a good condition. Well, it's an exponential with a equals 0, b equal p0. So you can write the probability that p, the power, the received power, is larger than p0, which is the average. هذا السؤال كان صح؟ Is 1 minus the probability that p is less than p0, which is the CDF. Now, in order to find this, you need simply to integrate. I put it directly, but you can just 1 minus integral from where? What is this? We integrate from what to what? Minus infinity to P0, right? However, where does it non-zero? Which range that the PDF is non-zero? From 0, so you can just write it from 0. خلينا نكتبها minus infinity. And then f of p dp. And then we write as 1 minus 0 to p0 of what? Now we write the PDF. It's 1 over p0, p to minus p over p0, right? dp. Now solve this, will give you this. And just opening up things, from P0 you will get basically 0.36. So the probability that you will see the signal larger than the average is only 30%. 2/3 of the time you get what? A signal that is it a good system or a bad system? الافرج عادة ايش تقول؟ لما يكون في شيء راندم ايش تقول الافرج؟ شيء اكبر من الافرج كبير ولا صغير؟ خليني اسالكم اكزام، لما الاكزام يكون 60 يكون المعظم طلع فوق الافرج ولا اقل؟ تو كده اثنين ثلاثة خابصين قاعدين جايبين أصفار كده عشان كده تزعل أنت لما تقول الناس اللي تعرف ليش يصير يطلع فوق. So basically you want most of the probability usually to have to be above average. اللي حاصل هنا إن معظم السيجنال معظم الوقت السيجنال is below average. The probability that you get a signal above average is third of the component. So it's not a good system. We need to find a way to enhance it. هذا شغل الكوميونيكيشن. بس واضح الفكرة من البروبابيلتي بوينت اوف فيو ايش سوينا؟ how do we do it? How do you understand the concept? How to interpret the PDF and the CDF? ايش علاقة الPDF والCDF different distributions, applications, any questions? طبعا ال A صار زيرو لأنه أنا هو معطيني ال PDF هنا and you can see that there's no shift here. So it starts from zero. لو كان P minus 5 مثلا يصير ال A equal 5. ال A is the shift. نرجع تحت فوق. اللي A هي is the shift. from zero. أي سؤال يا شباب؟ ها؟ هي مو كويس ليش؟ لأنه أنت عندك random behavior where most of the time the signal received below average. بالتالي الوقت يجيك سيجنال أقل من average. شيء مو كويس. السيجنال عادة تكون أقل average، ما تكون أقل من average. بالتالي الوقت يجيك أقل. So we need to do something about it. زي ما قلنا إيش communication. By the way, I forgot to announce that we will have a quiz next Sunday. Second quiz. I already posted it in Teams, but I assume some of you missed the announcements. So basically, yes. Quiz number 2 will be on Sunday, and the material will be chapter 1, chapter 2, sorry, the start of chapter 2 until today's day. Basically, okay. I have made the exam number 1 to about 10. Already moving to syllabus, no conflict مع أي شيء. It's a common example, and I did sections. All sections. I observed already all 6, 26, 26, 27. I will put announcement in due course. The best for you to understand. طبعا. على 7 8 ونص. المشكلة يوم الإثنين خاص بالحين في الإثنين. لا مشكلة إذا الجميع أوكي فيه هتلاقي واحد ثاني تبدأ يسمع فيه. Even when we have different problems, we stick to everything. Because we have countries who never do it. So I'll end the weekend table line. Right, let's continue. Now the last one is the Rayleigh distribution. I'm not focused much about it. The Rayleigh distribution هنا يعطيك the power of the signal distribution. The Rayleigh distribution يعطيك it has many applications. Like one of them is the amplitude distribution. So instead of the power, it's the amplitude. It's the square root of that. It looks like this. It starts from A again. So basically the shift here, you can see that this is the shift, which is A. So if A is 0, means that it starts from 0. And then it goes up and then down. It goes up quickly, down slowly. This is the way it goes. My PDF looks like x minus A multiplied by exponential x minus A. Yeah, I don't need to remember this. What you need to know and remember exponential binomial uniform الأشياء اللي جالس الأشياء اللي هذه you don't need to remember it, but you need to be able to work with it. هذا الCDF, this is the PDF, this is the CDF. So if I ask you, if I give you a problem with Rayleigh and ask you the probability that x exceeds a certain value, you need to be able to find it. It's 1 minus fx. Fine, I don't expect you to remember this, but in this you need to. So not to be remember. Memorized. We remembered as a concept, like memorized. الأشياء الثانية أتوقع أنكم فاهمينها عارفين اللي هي الإكسبوننشال باينوميال بويسون كل هذا كلكم عارفينه وفاهمين. طيب if you need anything complicated we'll give it to you. لكن الأشياء اللي تكلمنا فيها وخلينا عليها كثيرة يعني exponential I expect that you understand ما تحفظ you understand الفكرة هذه. It's just an exponential. اليونيفورم I expect طبعا هذه تجيبها من هذه. I expect you understand this concept هذه تجيبها من هذه. نفس الشيء binomial function. لا ما approximation no. أي شيء كذا complicated formula لا. You need to remember the EGX of the Gaussian and the rest set it very شوية معقد وما له داعي. الباقيين you don't need to memorize them, you need to understand how to use them. If you understand how to use them, if you understand ايش معنى PDF, you will be able to regenerate it. طيب the last thing that I would like to talk is the median. Median تعرفوا ايش median؟ وظيفة. Basically the median is the value, it's different than the average. في بعض ال application, بعض ال distributions, it's equal to the average. متى يكون الميديان equal to the average؟ It's what? Yeah, it's basically symmetric distribution. Right? لما يكون probability that it's less than 0.5, right? When you have a symmetric means that the average is here and it's the same shape around the little h Gaussian. Little h مثال ثاني. Exponential is it symmetric؟ بشكل واضح. طيب. ايش هو؟ Actually يعني هذا لا بيحصل. لكن اليونيفورم هذا اللي يمكن النص equal likely. Anyway, median is the value of x at which the probability is the value of x which the probability of 0.5 that the value of x does not exceed the median. So basically the value of x equals 0 such that the probability of x less than x equals 0 equals the probability that x is larger than x equals 0. In this case, x0 is the median. It's equally likely that x is larger and smaller than x0. Now, if I want you to find the median of Rayleigh distribution, how to do it? Of any distribution. Simply, you need to find the probability that probability x equal less than or equal to 0, the probability x less than x0, which is the median, which is fx of x0. This is equal to 0.5. So you need to find x0 such that this is equal to. So if you have the CDF, just plug. If you don't have it, you need to find it. So in this case, if x0 is given to you as this, just equate to 0.5 and solve for x0. In this case, x0 will be this. You can find it for exponential. You can find it for different applications. So in general, the median and the average are not equal except yes, when PDF is symmetric. Symmetric كيف يعني؟ around ايش السؤال؟ The average. In this case, the average equals إذا كان الديستريبيوشن كذا زي كذا الآن probabilities هنا قليلة وهنا كثيرة. Here the median وين يكون؟ يمين ولا يسار على الأرض؟ الحالة هذه هنا probabilities أعلى من هنا. Where's the median? يمين صح؟ To the right of the average. بالعكس to the left of the average. طيب, by this we are done with today's lecture, and next time inshallah we'll talk about conditional PDF and CDF. So note the quiz, it's next Sunday, and note the major exam. Thank you very much. See you next Thursday.